Get to the Money, Hacking POS and POP Systems, Dmitry Chastuhin. Donde hay dinero, suele también haber atacantes, y los servicios de retail encabezan la lista. En esta presentación se describirán las formas en las que un atacante puede lograr acceso a sistemas de point of sale o point of purchase, y se demostrarán algunas vulnerabilidades críticas de SAP POS, además de discutir los niveles de seguridad de los sistemas de POS modernos. Se hará una demostración contra SAP POS. Cuidado, luego de esta presentación, no vas a ser capaz de pasar tu tarjeta de crédito en locales de la misma manera. Dmitry Chastuhin es director de consultoría en seguridad de Herbscan. Trabaja en seguridad de SAP, particularmente en aplicaciones web, Java y soluciones móviles. Tiene reconocimientos oficiales de SAP por las vulnerabilidades encontradas y contribuye con el proyecto EAS-SEC.
Get out the money, hacking POS and POP systems. First of all, let me introduce myself as usual. As I said, my name is Dmitry and I'm a security researcher at ERP Scan Company. In ERP Scan Company, I'm responsible for penetration tests, security audits, and all research things related with different ERP systems and enterprise systems, and especially those related with SAP. And as I said before, I work for ERP Scan Company. It is a security company with headquarters in Palo Alto. Also, we have an office around the world, United States, Australia, Denmark, and our researchers found a lot of vulnerabilities in different ERP systems and enterprise applications. We did a lot of presentation about our findings, and I'm gonna do another one. So, let me start. At this slide, you can see my agenda for today. First of all, I will make a little introduction in point of sale world. After that, I will tell I will mention some other researches about POS. And next will be our motivation for this research, why and how we choose our targets. We'll also tell you a little about the business day of typical store, because it is necessary for understanding how POS works. And we are going to describe architecture of two POS systems, SAP and Oracle Micros. And of course, I will describe some of our findings. We are going to show how an attacker can use these issues for their profits. And finally, we talk about solutions, mitigations, and some conclusion words. And let me start with history. It was 1871 when James Jacob Ritchie opened his first saloon. But there was a problem. Some of Ritchie's employees took money from customers and put them in their pockets, instead of depositing money intended for paying for food, drinks, and other goods. So that's why James invented a mechanism that could record the cash transactions which was made in his saloon. So you can see how this invention looks on the screen. Yeah, and you can see James Jacob Ritchie. So it looks like clock with keyboard. The main idea was really simple. When customer made a purchase, the cashier should push a special button and the time at the clock increased. At the end of the day, Jacob could compare the amount of money in the cash box with the indication on these clocks. But of course, the system was not ideal, and tricky sellers could only pretend that they used this cash register, or even they can click other button with lower price, or when no one saw, he acted even easier. They just moved errors back. This story is an excellent example that issues related with security issues related with this type of systems happened and arisen from the very beginning of their existence. In our days, point-of-sale system is a combination of software and hardware that allows merchants to take transaction and simplify day-to-day business operations. Anyway, the most familiar example of POS system will be the checkout counter at a retail or grocery store. However, there are many more forms of point-of-sale systems used in many business types like restaurant, casino, cruise liners, hotels, etc. But what about security? Is it still an actual problem? If we Google about POS hacking, it will return us a lot of results about hacking POS terminals as a hardware devices, but not about cashier workstations. We decided to check some of these previous works. Some of known research have been made before in 2012 and 2016. Let's do a quick tour through the most interesting of them. And we start with Lukas Zajchowski, who presented his research at Black Hat US 2014. He analyzed small and large incidents and demonstrated some security problems with POS devices. For example, he showed that MagStripe cards contain unencrypted sensitivity data that can be cloned. Or EMV chip contains MagStripe equivalent data encrypted too, and this data also can be dumped from RAM. The other research, authored by Ross Anderson at the same Black Hat US. He wrote about the relay attack and no-pin attack. An attacker could control a terminal and as a result, trigger the card and terminal and provide a transaction. Niels and John Butler gained a great result in POS terminals. They found a lot of default passwords and hard-coded credentials. A code execution in context of payment application and control anything in POS terminal. They can upload and execute code on terminal using USB or Bluetooth connection. And additional can do anything using EMV card and stake-based buffer overflow vulnerability. Peter Fillmore, in his research, said about clone cards, clone transactions, and payment transaction flow. As a result, he said that we can't clone cards economically, but we can clone transactions. And finally, Stawomir Jacek, and his talk, Hacking Challenge Steal a Car. It's not clear, actually, from the talk name, but Jacek wrote and presented interesting tool, GAT taking tool for man-in-the-middle of Bluetooth connections. One of possibilities is to make man-in-the-middle attack against mobile POS devices and sniff sensitivity and intercept sensitivity informations. At this slide, you can see his man-in-the-middle demonstration from Black Hat US. So, the question is, why did we choose POS software for our research? Before answering on this question, let me show you a typical architecture, common architecture of the payment process. How does it work? First, consumers swipe their cards or merchant POS devices to purchase goods and services. Anyway, the POS devices send the credit card data to merchants' POS systems. Secondly, the POS system contacts the PSP, or payment service provider, who contacts the designated acquirers for transaction authorization, depending on what card brand was or card type was used. Then acquirers use the card brands networks to contact credit card issuers. Issuers return an authorization status to acquirers via card brands network. And finally, the acquirers then pass on the authorization to the PSP, who forwards it to POS system and which complete the transaction. Actually, all this process, all this communication occurs in a matter of seconds. We dedicated the gray part of this scheme as a payment process. All connections here is encrypted and generally security level is high. But the rest part is not so fortified, actually. Researchers we have been talking about are somewhere here, between customers and POS hardware, or here, between POS hardware and POS software. We thought, what will it be if we try to attack not customer or terminal, but the back end of the store systems? What will it be if we can manipulate prices or other settings like sales information or new discounts? Anyway, so that's why we chose this area. But first of all, we should say few words about typical business day in POS system for the best understanding of processes. To start our sales, we need to open store, right? So every day manager opens the store. After that, manager open terminals and cash desks. Cash desks and terminals get updates from the server, from back office, get new prices, new discounts, and etc., and synchronize business date and time. After that, cashier works normally all the day until then. During the business day, POS system processes a lot of information, like new prices, transactions, logs, information about sales, a lot of. After the working day, store manager closes terminals and cash desks. All terminals and cash desks send information about purchases, log information to the back office, to the server. After that, manager closes store and no transaction can be done until the store is closed. Now, how did we choose our target? How did we choose POS systems? Based on some awards, the following companies are the best of the best software providers who specialize in retail technology. We decided to check large vendors, leaders first, and we started with SAP company. What is SAP? SAP is the world leader in enterprise application in terms of software and software-related services revenue. Based on market capitalization, they are the world's third largest independent software manufacturer. And a bit information about SAP POS. The description from SAP side says that SAP POS is a client-server point-of-sale solution known as Traversary Transactionware, GM prior to its acquisition by SAP in 2005. The architecture of SAP POS is one rather typical for other point-of-sale solutions. It consists of POS client application running on the cash desk, store server application running in the store's back office to serve connections, operative and administrative needs, and applications running in the head office to allow central configuration. To make it more clear, this is a POS terminal client where cashier works. Here we can see cashier and manager functions, terminal information window, input area, instructions, receipt area, and total and status area. It is cashiers and managers who use this interface. Here you can see other component, Express server. It is the heart of POS system. Administrator can start and stop Express application, look for current actions, check status, configure backup service, and debug application. It should be always on for a correct SAP POS system work. The next component is Store Manager. There are several units here like administrator, file maintenance, cache management, price management, a lot of them. And similar to store manager exists store configurator. There are some similar menu, like transaction functions, data capture, terminal, etc. But the main thing, after configuration, administrator converts settings to special file format. And for the next few slides, let me split our analyzing of SAP POS on 3 parts. You can see these parts on the screen. Part 1, processes between head office and store server. Part 2, communication between store manager, Express POS server, and database. And part 3, communication relation between POS client and Express POS server. And let's start with part 1. So we have store configuration in head office and Express POS server on store server. Store configurator is software with GUI. It used to configure everything. Pay attention. Everything in the POS system. Users, terminal appearance, prices, security settings, everything. Using GUI interface, system administrator changes all what he needs. After that, the configurator converts the setting into special files, save them in parent directory, creates a new file, new parent.trg, and after that, administrator needs to copy these files from store configurator, from head office to store server on Express POS server directory. We know this TRG file especially because it's like a trigger. When Express server application searches the file every 30 seconds, if it's find the file, this trigger file, then all parameters will be checked for updates and will be applied. After that, server deletes the trigger file. That's how administrator applies new settings on store server. Here you can see file architecture of Express server. The most interesting is parent directory because there are all configuration files in it. For example, the file cnammask.cmk is responsible for masking card in receipt, or cashier.clg contains information about cashiers and managers of the POS system. And or other example, layout.ui0 describes interface of POS client. Okay. Next part, part 2, communication between store manager, Express server, and database. Store manager, again, it is software with GUI used to configure store settings. We can divide all possible functions on 2 parts by using ports. The first one is database port. And in this way, store manager resembles a store configurator, but it works directly with database and write all changes in database directly. And the second part is port 2202. So if we'll try to connect on this port, it will return us a welcome message with POS build version and version information. Help command shows us possible operations. Here they are. You can see commands like show terms, which will show you active and non-active cash desk, including store number, terminal number, cashier number, etc. Next command, mon-term, is the most interesting command because it let the user monitor and see all whatever appears on the receipt window of the POS terminal from the cash desk. Or we can open or close terminal. Also, there are some interesting commands that allow you to change cashier information. So let me show you a first. demo. So, on the left side, you can see the interface of SAP POS client, and the right side, you can see attacker's console. We just connect to the telnet port 2202 and execute command show term all. That's how we can get list of cache desk. After that, we execute command mount term with number of our victim, and we'll try to buy MacBook. And as you can see, an attacker can see everything about, include price, information about credit card, etc. And all these things without any authentication. Okay, back to our presentation. Yeah, vectors. We found one interesting store procedure in database with name SSP insert backdoor. Yeah, sounds interesting, and we check this procedure. What this procedure does, it creates new user with name back and password. Guess what? Door. Yeah. Okay. Also, we made a little reverse engineering of the Express server binary file, and it was not so hard to find much more commands. There are over 74 methods with the same structure. In opposite, 70 methods shows in help from telnet. There is no information about these methods in official documentations, but we want to tell you about the most interesting of these methods. For example, there is a method APM validate password. If we have a look on the method's output, we can see that this method returns different APM code, which depends on the incorrect password or incorrect login or correct login and password. That's how an attacker can brute force, first of all, brute force cacher login name, and after that, brute force cacher password, because there is no limit for trying. So, but brute force is not an elegant way for getting access to the cacher account. That's why there is other way. We can simply change cacher password using two commands without authentication. There is no authentication here. An attacker can monitor terminal for searching the store manager number, change its password, and can do anything he wants on it. And another interesting method is file operations. We can read files on the server using these functions without notification. File read method. So let me show you other demo. Okay. Okay. There is again attacker's client, a console, and we can send command APM validate password with login name 4444 and password. And this command returns us APM code equals 0. It means it was correct login name and password. If we specify correct login name and incorrect password, we'll get APM code equal 1. Yeah. And if we specify incorrect login name and any password, we will get APM code equal 10. It means incorrect login name. That's how an attacker can brute force login names and password. Okay. Now, come on. Now, other thing. We can log in into the cash desk with username, cashier name 4444 and password 8888888888. And after that, we can use function APM reset password, specify cashier identificator, in our case it's 444, a new password. In our case it will be change P1. And that's all. Now we can use this new password for getting access to the cashier desk. Okay, CHANGEB1. Okay, got it. All these things without authentication. Yeah. Thanks for guys from SAP. Okay, great. So let's talk about communication between cashier workstation and store server. Between cashier and store server. POS clients connect to the store server and talks with it using port number 2200. All information like transaction, configuration, and maintains data is transferred using this port. At the beginning of the day, when the store manager opens terminals, it sends a request, something like, hey server, I wake up, send me new parameters, price changes, sales informations, new discounts, etc. And at the end of the day, when manager closes terminals, and when manager closes cash desk and close store, POS workstation sends log files to the server. This process is called polling. And of course, right after each purchase, the POS client sends data about this purchase to the server, to the back office. So we captured traffic between client and server during the polling process and discovered an interesting thing. As I said before, during the polling process, POS client sends logs to the server and also downloaded new parameters. We noticed that packet with parameters request looks like this. Packet contains type of request, length, and information about what file POS server should return in response. And what's interesting, there is no information related with session or authentication. We repeated this request from non-terminal computer, and it returned us the same result. It means there is no authentication between POS workstation, between POS, between cashier desk and back office and POS server. After some experimentals, we got working POC for reading any file from the server's file system. Protocol rivers show us that our possibilities are much more than just reading files. There are a lot of message types in this protocol, like B, C, D, E, etc. For example, R is for file request send. What if we made a file send request? It sounds like the reverse function look like this type of request allow us to upload any file on the server without authentication. And yes, we can do this. For that, we must send only 3 packets. The first one is S-type request, which contains packet length, file path on Express server, where we will write our data, and size of sending data. The second one is F-type packet. This packet contains length and data that we want to write to the server. And finally, the third packet, this packet means end of file transmission. And after that, Express server handle request, a new file appears on the server. If everything was correct, server will send us G-type message. It means good. Interesting thing is if we send packet with incorrect length, Express server will delete the file specifying the packet. Okay, to resume, an attacker can use port number 2200 for communication with SAP POS server for uploading, downloading, and deleting files from the server without any authentication. Let me show you another demo. On the left side, we have Express server and directory c/poc, and you can see console here. We just send a simple request and new file appears on the POS server with text hello world. And also we can send other requests. That's how we can read any file, and we can read this hello world file. Or we can send third request, and we will get, and that's how we can delete file from the server. Yeah. Yes. Very, yeah. Everyone loves applause. Okay. As far as store manager connection with Express POS server is not validating, POS client connection are neither validating. It means we have two vulnerabilities, and let's see what can we do if we mix them. The next part of my talk contains some little thoughts about possible attack scenarios. But before that, let's have a look at the common store architecture. There is a store server and POS client in it. In addition to that, there are some local peripheral devices like barcode readers, waves, card readers, and others. Some of these devices, like waves, can be accessible for customer and for attackers too. How attackers can use them? Of course, an attacker can use them for getting access to the internal store network. Like here, you can see that network cables are available for an attacker. Or, like here, we can easily get access to the internal store network. Or like that, we have a router with POS sign. So, it means that getting access to the store network shouldn't be a problem for an attacker. As a last resort, an attacker can get a job as cashier for that and earn some money, of course. Sorry. For their attack, an attacker can simply replace a device like Wave by his malicious Raspberry Pi, for example, and make some fun. So, we are inside network. What is next? But first of all, let me remind you some facts. So, what do we have now? We know that store configurator creates configuration file and Express server will apply them if it finds a new param.trg trigger file in special directory. Second, we can write any data we want in any file on Express server using port number 2200. Third, POS clients update their parameters after opening cache desk. And finally, we can close and open POS terminals and cache desk using telnet and port number 2202. All we need is an access to local network. And now we know how we can get inside internal network. So the whole scheme of attack works like this. An attacker writes configuration file that he wants on Express server using port 2200. Configuration files can be very different. It could be a credit card mask, it can be new item price or new discount. After that, an attacker writes new param.trg file on Express server using the same port 0022. Express server finds the trigger files and applies new attacker's settings. Some of them it tries in database like promo information, for example. After that, an attacker needs to deliver new settings to the cashier workstation. And for that, he sends a closed terminal message on Express Telnet port. Or as an option, he can wait until the end of business day. After getting closed terminal command, Express server sends a closing request to all POS workstation, to all cash desk. After that, an attacker sends an open terminal message on Express server Telnet port. And Express server opens all cash desk. And during opening process, POS workstation, all cash desks, sends request to the Express server and downloads attacker's settings and apply them. That's all. We can control almost every parameter in SAP POS system by this way. For example, we can change price for any item or create special discount for us. But we know everyone like remote command execution and what is a vulnerability if there is no remote command execution. And you're right, we think the same way. That's why we found one more interesting thing. But we noticed that when Express server application starts or updates parameters, it searches for xps param.bat file and stoptn.exe file. And if they exist, it will execute them. And nothing can stop us now from uploading and getting full control of the Express server machine. So the whole vector for getting remote shell is we write xps param.bat file with back connection commands in the main Express server directory. We write new param.trg in param directory for triggering updates. After that, we are waiting for 30 seconds until Express server finds the trigger file. After that, it deletes trigger file, searches for xps param.bat and executes it. We have written a reverse shell so Express server make a back connect to our specified IP address. Now we can send any command that we want, and all these commands will be executed as operating system commands. Final demonstration. Oops. Yes. Okay, we have cash desk. Let's make a common purchase. Let's try to buy MacBook Pro. It cost almost $900 and tax. Okay, we'll pay by Visa card, swipe it, and yeah, because the amount is big, cashier should enter his login name for approving, and that's all. Customer gets the receipt, and that's all. Now, we plug our malicious Raspberry Pi with our exploit into internal network. And our exploit is trying to find Express port 2202, and when it finds it, he will start uploading new parameters. And first of all, we should get a shell from the server. And yeah, got it? We got a shell. We can execute anything on a server. But after that, we need to change some prices or something like that. And for applying new settings, we must close terminal, and after that, open it. For that, we send close terminal message, and as you can see, workstation cache desk was closed, and after that, again, we send open terminal, And during the polling process, cash desk downloaded and applied all new parameters. And what if we now do exactly the same purchase that we have done at the beginning? We'll try to buy MacBook Pro again. Now you can see that MacBook Pro cost $3 instead of regular price, $819. Pretty good price, okay. I'll take it. I pay by Visa again. I swipe my Visa card. And fill expiration date. Okay, we can see total savings. Good deal. Yes. Okay, that's all. We bought new MacBook Pro, and additional thing, all credit cards, information about all credit cards are sending to the attackers. And let's check receipts from first purchase and for the second purchase. We can see, we can change even receipt. We can change price. Oh, sorry. Let me move it. We can change price. We even can type the whole information about card number on the receipt, because it's very often when after purchase customers just trash receipts, and yeah. And of course we can change the footer. Yeah, we can do almost everything. And fixes. Now let's talk about fixes that SAP made. The patch appears in July with title Missing Authorization Checks in SAP Point of Sale Retail Express Server. The description says that a new parameter appears after the patch which determines AP address that accept connection, blah, blah, blah. It's okay. Looks like SAP closed one vulnerability, which they add something like ACL files for telnet port, but they forgot about missing authorization check between cache desk and express server. The main vulnerabilities still exist, and we still can execute any code on the operating system. We can change everything. So, okay, we think maybe we should say SAP about this, and SAP team was surprised, and they extremely fast made a new patch. But yeah, they said, oh, really? We forgot about remote command execution. And they create a new patch. Another security patch was released in the August. SAP implements new security checks between SAP POS clients, between cache desk and back office, between SAP POS clients and Express server. But again, patch brings new problem. Now everyone can crash Store Manager using new security features that previous patch brings. And finally, you can see all patches that need to be implemented on the server. If you have SAP POS, please implement this. Okay, enough about SAP, a few words about Oracle. We wonder if everything is bad with the security of other POS vendors. Okay, let's mention one more POS system, Oracle Micros. So what is a Micros? Initially, Micros was developed by the same name company and means Modular Integrated Cash Register Operating System. Micros developed hardware and software for casinos, cruise liners, retail, restaurants, hotels. In 2014, Oracle bought Micros, and now we know this product as Oracle Symphony. If we talk about the security of Micros, it is worth mentioning that the attackers have already tried to compromise the Micros for getting profit. In 2016, many internet journals wrote that Micros was hacked. But after the fact-checking, we found out that attackers got access to the Micros customer portal, POS workstation, or client's data wasn't compromised. As practice shows, finding a server with macros is not very difficult. Well-known methods like search engine like Shodan, Google, on Census are great for this. On this slide, you can see the result of searching in Shodan search engine. Let's have a brief view on the architecture of macros. Again, we have three main parts here: workstation, back office, head office. That is how administrator interface of Oracle macros looks. For me, it looks much modern than SAP POS. But not all macros components have such a clear interface. For example, if you try to configure a workstation, you will see windows like this. At first glance, it's very unclear what they want from us. We didn't find in official documentation what exactly it is necessary to enter in this window. And only search in special forum enable us to find the answer. It turned out that in order to gain access to the configuration work possibilities, the user must perform a number of mathematical actions with displayed digits. He must multiply the first two digits and add the fourth and the sixth number to that. It's really strange why they did it, but anyway. That's how macros protocol looks. You can see that macros uses HTTP for communication and sends mix of binary and XML data as a payload in POS or in POST requests. Okay, let's go closer to macros vulnerabilities. Honestly, we didn't have enough time for researching Oracle macros, but anyway, we found some issues. We found possibilities to get information about POS workstation, database, issues that allow us to read any file from server again, and denial of service attack. That's how one of these information disclosed looks. An attacker can get information about version, about hardware, about configuration, information about tables, because macros is often used in restaurants. This is an example of arbitrary file reading. An attacker can read files like symfony install.xml or dbconfig.xml that contains usernames and an encrypted password for connection to database, again without authentication. Also, I'd like to share some default values of macros, like default username macros, default passphrase for encryption, default database account. Maybe it will be helpful for someone during the penetration test. Okay, conclusion. As you can see, POS, it's not only pin pads or POS terminals as a hardware. Also, it is a big infrastructure behind. Our small research shows that the state of security of this infrastructure is not as good as we would like. Simple vulnerabilities and bugs like missing authorization checks still exist and brings big potential for the fraud and attacks on customer data. So that's all from my side at this moment. Thank you very much. Gracias. If you have any questions. Thanks. See you on the party.